Assalamu alaikum. Today we're gonna have another very interesting class. We're gonna start this lecture by having a brief on the soil formation factors. Then we're gonna talk about something really very interesting in soil, which is the soil horizons. Without further ado, let's begin. A fundamental question that every one of us would ask him or herself is how the soil is formed from the rock, how the rocks are turned into soil. And to answer that question is very easy. It's because we have 5 different soil formation factors and we abbreviate them into CPORT, which basically indicate for climate, then paramaterials, then O for organisms, R for reliefs or topography, and T stands for time. So if we look at each one of these ones, if we start with a climate which includes the temperature that really affect the biological and the chemical weathering processes, and the water, the rain, which is also a very important factor for the weathering process. And then you look at the organisms, which includes the plants, the animals, insects, and ourselves, the human. All of these organisms interact to each other. They are, for example, adding materials or decomposing materials or transporting the soil and moving it, or maybe weakening the soil or weakening the rocks. And therefore, they contribute to the formation of the soil. If you look at the barren material, as you remember, we have some of the rocks which are really hard, and therefore they takes a long of time to be broken down into soil. And some of the types of the rocks are very easily eroded, like the one we see along the way to Muscat Express. Those rocks, for example, they are sedimentary rocks, and they from the look they really seems to be very easily eroded because they're basically like cemented soil, and therefore it can be easily converted and broken down. And then you have the topography. So you know that with the slope, water would have a great influence compared to a flat surface. When you have a slope, then the water can move very fast, and therefore it can erode things very fast and can like help to make the process of weathering very fast. And then you have the slope aspect, and the slope aspect is basically describing the mountain. For example, assume that one face of the mountain is facing the sun most of the time during the day, and therefore it is receiving a lot of solar energy and radiation, and that would affect the temperature and the process of weathering, compared to another face of the mountain which is not receiving the sun. So you would see that the one receiving the sun would have faster and more weathering processes. Now, something very important to keep in mind, that all of these 5 factors are basically exist in the same time, in the same place, and they act all together. So you cannot, for example, separate the topography, because the topography describes the features of the land, whether it's a flat or a slopey. The organisms always there, the type of the rocks always there, and the climate is always there, and all of them acting at the same time to form the soil. However, you might also ask yourself a question. Well, among these 5 factors, is there one which we can really say that it's the most influential factor? And the answer is yes. The answer is the climate. And what we mean by being influential is that it is the one which can really influence the weathering rate at a larger scale. Let's look, for example, at water. When rain happens and fall into the surface, okay, part of this water can infiltrate into the soil and do a lot of changes inside. Or some of it might run over the surface. Those, or this part of water which runs over the surface, would form a wadi at the end of the day. And as the water is flowing and the wadi intensity increases, then the water would carry out with it the rocks, and the rocks, as it flow in the wadi, it hits each other and broken down. And also the wadi can erode the soils, and therefore it can transport it from one place, the upstream, to the downstream. Along the flow of the wadi, the water is mixing these materials, dissolving some of the chemical compositions. And water, remember that water is very important for the physical and the chemical weathering, because physical weathering, you break it down into smaller pieces. Chemical weathering, you actually dissolve things and change the internal structure, the chemical properties of that particular matter. So water would dissolve some of the minerals like calcium carbonate, and because of that, these minerals can be transported to another place. Or along the flow, some of these chemicals might react to each other to form another type of a chemical. That's why water is the most influential factor among the soil formation factors. Now, you would say that, okay, we have all the 5 soil formation factors acting together, but how does the soil really form from a rock into different layers, into a deep soil, that if I go into my farm or any one of your farms, or go outside and dig a pit, then you would see that the soil is really deep. How this deep layer is formed with time. And to answer this question, I want you to imagine with me. Now, imagine you are watching the story of soil formation from the rocks into soil. And I want you to assume that we are in a humid, warm climate, which means that we have a lot of water and we have temperature. So it creates a maximum weathering rate, meaning that the weathering process and the conversion from the rock into different layers of soil would be maximized and very fast. Now, let's start with the first picture to the left. Now, you have a rock and you have rains that happens. So the water of the rain goes into the fractures of the rock and go down and start dissolve and move things and react with it. And because of the variation in temperature, some of the rocks here start to be broken and disintegrated into a smaller pieces. Of course, with the help of animals that could walk on these rocks, or other factors like the winds or like the water flow and so on. And after hundreds of years, this rock would be broken down into a smaller sizes, into the soil size, into 2 millimeter in size. So here, if you look at picture 2, a simple organisms. Now, at the bottom, you have the rocks. Above it, you have a layer of soil started to be formed. And at the top, because you have water, you have a beginning of life. You have some organisms like fungi, like bacteria, like some insects start to exist at the soil surface. And you have also some vegetation like little grass with their roots entering into the soil, creating some pathways so water can go deeper and can move things and can dissolve things and can be really effective. Now, with time, you would start to form another new layer. If you look at picture 3, because you have now these organisms and you have plants, it will add organic materials. And because of these organisms, you might have a mixing of the inorganic and the organic material at the top. So at the top of the soil, you will form a layer that is a little bit dark in color, and it's mixed between organic matter and inorganic matter. Below, you have the soil, which is basically still is just 2 millimeter in diameter and have almost the same chemical properties like the rock. Now, what happens with the time that plants also grow? And because you have organic materials and some of the seeds might grow and it will enhance the growth of plant, so you might have even developing some trees. And with time, these trees would spread with their like roots and with their seeds, and they might form a forest because we are in a humid climate, favorable condition. Now, when you have a forest, that means you have a lot of plant material on the surface. You have a lot of organisms also in the soil. You have a lot of animals that are all existing in the soil surface. So some of the changes would start to form. When these plant materials fall into the surface and the animals died, they decomposed by the organisms, and then they will form a layer which is purely organic matter, dark, really black in color at the soil surface. It's only organic materials. Below it, you have the layer which you have a mixture of organic material and also minerals. And because you have water and the water can pass through the organic material layer, it reacts with it and it will form an acid called organic acid. And you know what acid can do. The acid would dissolve things. So when this acid passed from the layer, the black layer at the surface, the organic material, into the layer which has a mixture of organic material and inorganic material, it will actually dissolve some of the minerals like iron, like clay, for example, and it will move them down into the soil, down in the subsoil. And then it will form there a layer where it will accumulate all of these materials, all of these transported or translocated materials from the top. And because at the top, between the layer where you have this accumulation and the layer which has mixture of organic matter and minerals, because there you lost some of the materials, it will appear white in color and it will form a layer which has lost the minerals. So now if you look at picture 4, and after all of these process, you will see that with these conditions and after a certain time, like hundreds and hundreds of years, we end up with a 6th layer. We have a rock, above it we have a layer of soil that has a similar properties to the rock, and above it you have an area where you have a layer of accumulation, and then above it you have a white layer which lost the materials, and above it you have the layer of mixed mineral and organic material, and at the top you have the pure organic matter layer. So now we notice something, that each of these layers is different than the layer below, but each one of it has exactly the same physical, chemical, and biological properties. What do we call these layers? Basically, we call these layers as horizon. So horizon describe a parallel layer to the surface. Each of this layer is completely different than the layer below or above. That's why we distinguish them as different layers. But if you look at the property in each layer, you will find that it is the same. It is the same. So if you look at the top layer, it's only purely organic material layer. Below it, you have a layer that is purely mixed of organic and inorganic matter. And below it, you have a white color layer which lost its mineral, and so on and so on. So we describe these as horizons. Each layer now, to distinguish them, we give them a name, we give them a letter, and those we call them horizons. And each one of them is given a letter, as you would see. You have the O horizon, which describe the organic material layer, and then you have A horizon, which basically called the topsoil and describe a mixing between organic and inorganic material. And then you have the E horizon describing the layer which lost its mineral content and becomes white in color. And then B horizon, which is the zone of accumulation. C horizon, the layer where it is having a soil that is just 2 millimeter in diameter, but it has the same chemical properties like the barren material. And at the end, you have the layer of the rock, R. Now, if we want to know more about each layer of them, we have to give them a further information. So let's start with O horizon. O horizon basically, as I said, describe the layer which has purely dark black in color and it's purely organic material. Now, something to remember that those organic materials, where does it come from? Basically from the plants, leaves, the roots, or the dead animals, and all of these things. And basically they are not saturated with water. Sometimes you can see the plant material on it. You can distinguish them. You can see that, oh, this is an organic letter, but I can see, for example, here's a stem, here's a root, oh, this is like a bone of this animal, and so on. It's not highly decomposed. And this one we call it OI. We give it a little letter I, and we call it fibric, which describe basically it's an organic horizon, O horizon, with a recognizable plant and animal parts. But sometimes these materials are intermediately decomposed, and here we give it with the O horizon, we give it a small letter called E, and we call it hemic, which is describe intermediate decomposition. And sometimes this organic layer is completely turned into a fine material, completely decomposed, highly decomposed, and in this case we call it OA, and we call it sapric, which describe highly or complete decomposition rate. So these little letters I, E, A describe the decomposition degree, and it only comes with. Now, A horizon is completely different than O, because as we said that A horizon is basically a mix between organic and inorganic materials that has been mixed due to the soil organisms or the animals which move things from the surface and add it down into this layer. And also it can happen because of the other like the roots and so on. So it's a little bit dark in color because of the organic materials. E horizon, you remember that white layer that lost its material? This is, we call it E horizon. It's a layer where it lost its material by the water or by the acids, like the case into the story. For example, it loses clay, or it can lose some of the chemical content like aluminum, like iron, by the downward movement into a deeper layer. Now this layer becomes white because it reveals the real color of the soil. It loses the coat, the paint of the soil. These chemicals basically are the paint of the soil. That's why it becomes pale, it becomes white in color. And we call it alluvial horizon by E. Alluvial horizon, which describe the horizon, the E horizon, which has lost the material. Yeah, now you would see that this word alluvial started with E. That's why this is E horizon. And the process of the losing is called eluviation. All right? Now B horizon is the horizon which exists at the subsurface, meaning that it's a little bit far from the top surface. And B horizon, as you said in the story, it can be formed by two different things. It can be formed either by turning this soil into very fine particles, like smaller than 0.002 millimeter in diameter, in situ obliteration or weathering, or it can be as the story. It's basically, it can be formed as the story. It's accumulated materials from the overlaying layers, accumulated with clay, organic matter, aluminum, or anything that has been lost from the E horizons through a process called illuviation. Started with I. It's a different than illuviation that forms E horizon because that one started with E, and this one is illuviation with a double L, which is describing the process of accumulation and forming the B horizon. Now, C horizon, as we said, it's basically a soil. It's basically a rock that has been turned into a soil, into fine particles, and it has the same properties like the rock, inherit the same properties like the rock, because it is far away from the pedogenic process, from the soil formation factors and the soil formation processes that happens at the surface, like the wind, like the water, like many other things, like the animals. This is far away, it's deep, just above the rocks. And it can be like formed from a beach of sand or blown silt or glacial till, and so on and so on. And finally, then you have the R horizon, which is basically in a simple way, the rock. Now, okay, we know that, yeah, the soil formation factors form different layers, and we call them horizons, and then we distinguish them by O, A, B, and so on and so on. But the question now, can we find all of these horizons exist in the same place? Let me make it in a simple way. If we go outside here in Oman and dig a pit, can we find all of these horizons, 6 horizons, in that place? The answer is no, because it depends on the factors. For example, in Oman, it's almost impossible to find O horizon. Why? Because to form O horizon, you need a huge mass of organic material, like you need a forest, like you need really, like it's purely organic. So it's very difficult. We don't have huge mass of plants in Oman like a forest. But you might find in Oman, for example, A, B, C, and R, for example, like this. Even in some of the humid areas, like for example in many European countries, you might not find O horizon. Why? Because if you have at the surface, instead of forest, you have just grass, then you will not have O horizon, because you don't have that huge mass of plant. You would have A horizon, only A, then maybe B, and then C, and then R. You might not even find E. So again, the answer to this question depending on the situation. I hope that you enjoyed this class, and thank you so much, and take care.